Now we are going to study the bond fission, and then we will study the free radicals. Organic compounds are made up of covalent bonds. That is, in organic compounds, there are covalent bonds. Now, a covalent bond, actually, we will see a covalent bond is a pair of electrons shared by two atoms. Shared by two atoms, just like this. I will show this A, B. Now, this is a covalent bond. It is shared by two atoms. Now, organic compounds, when the organic compounds undergo the reaction. Now, organic compounds, a covalent bond is actually a pair of electrons shared by two atoms. Now, organic reactions involve breaking of bonds. Breaking of bonds take place when organic reactions take place. Bonds. So when the two atoms or when two atoms or two species, when two atoms or species joined by a covalent bond, break, when two atoms or the species joined by the covalent bond separate, the process is called bond fission. It is known as the bond fission. So bond fission, when fission takes place, that it is called a bond fission, or we call it cleavage of bonds also. Cleavage of bond. In cleavage, the bond breaks and the two atoms or the two species joined by the bond separate. So this bond fission depends upon, number one, nature of the compound. Number second, depends upon the conditions of the reaction. Number third, nature of the attacking reagent. Because bond fission usually takes place when a reagent attacks the organic molecule. So the fission of bond we can explain is of different types. We can explain. There are two types of bond fission. We will explain here. Bond fission takes place in different ways. That first we will explain the first method, that is homolytic fission. First is homolytic fission. Homolytic fission, this type of fission takes place in such a way that each separated atom receives or takes one electron from the shared pair. That is, the fission is symmetrical. It is called symmetrical fission. that is the two atoms separating atom. When the atoms separate, each atom takes one electron from the bond pair. I will show it here that it is AB, bond between AB. So when the cleavage takes place, A takes this electron pair which was shared, gives A this one having one electron, plus B having one electron from the shared pair. So this is the homolytic fission. I will show it in the another way. B, we will show bond fission. Now one electron is taken by this, we show it by a half arrow, and another electron we will show by here, it is half arrow. That means one electron is taken by the one atom and another electron is taken by the another atom. Now here we see the species which are formed, that's A and B. Each species has one electron, or we call it odd electron. So this is the odd electron. So odd, this species, the species formed in the homolytic fission, the organic species formed in homolytic fission is having odd electron, or we say it is unpaired electron, is called a free radical. So this species of form is called a free radical. Now free radicals, this I will say this bond fission, or we can say the bond fission, homolytic fission, is a common mode of fission in the vapor phase. And is initiated by high temperature, catalyst. It is initiated by high temperature catalyst or the ultraviolet light. So this is the homolytic fission. It is symmetrical fission because each from the bonded pair each receives one electron. Now the species so formed, you see there is no charge, so they are electrically neutral. That is, we can say free radicals are electrically neutral. Electrically they are neutral. Free radicals are electrically neutral. We can say that free radicals are electrically neutral. I will show it here. For example, this is the chlorine molecule joined by the covalent bond. Now, when this bond breaks, fission takes place. Here, it will get Cl. It has one electron from the bond pair, and plus another Cl atom. It has one electron from the bond pair. So it is the free radical. Similarly, if it is methane, I will show it in this way. I will separate the one hydrogen atom by the bond. I will show the bond with carbon, and this bond breaks. It will give the methyl free radical, a carbon, and hydrogen free radical. That is how molecular fission takes place. Similarly, if we take the hydrogen gas, in hydrogen there is covalent bond, so the bond breaks, we will get the hydrogen, there one atom